Okay, good Friday morning, everyone, and welcome back, or welcome to the Backyard Naturalist, brought to you by the Urban Ecology Center here in Milwaukee. My name is Tim, and I will be your host today, August 16th, for an episode I've been wanting to cover for quite some time. Um, it kind of seems like an episode where superlatives will rule. Certainly one of the coolest organisms we've ever featured in so many ways. It's not a super common denizen of our backyards, at least here in Southeast Milwaukee, which is maybe one of the reasons why it wasn't covered sooner in our 5-year history. As you head further south, they do start to become more common as a backyard resident. We've certainly seen them if we've watched media, cartoons. They're the blind wood-eating critters that will just mow your house down in a matter of seconds. And I do apologize for the I did my best this week. I in my creative elements of termites of endearment. So I hope you can sit back in front of whatever device you happen to be by, sip a nice summer beverage if you have it, and we will listen to the story of termites in episode 50 of season 5 of the Backyard Naturalist. Okay, so, and I will, whoops, also say thank you so much for tuning in today. Whether you're watching live on Friday morning or tuning in later on YouTube, we're glad and honored and humbled and all of the things that you're here and spending time with us, especially now that it is season 5. Whoops, a little more sensitive today. Season 5 is almost done, and we are starting to 2 more weeks until the season finale and 3 weeks until the opener of season 6. So we are just kind of waiting for these registration details to be worked out internally, which is about as easy to do as ingesting wood without a specialized gut biome, but it will be available soon. We're really happy that we're still able to bring these weekly lectures for free. And we're super happy that many of you have been able to support the series with your subscription. Nothing is going to change with the subscription next year. So if you enjoy your weekly time, we hope you can continue with an annual or seasonal subscription. You'll still get hassle-free access without the need to register, and you will be invited to the subscriber potluck, which this year will be at the globally unique Cedarburg Bog. But one thing that is changing is that we are separating out the field trips, so that we can put a little more intention into what we offer as we explore Milwaukee's backyards, which up until now has kind of been, hey, where does Tim want to go? And let's go check out that place. So starting in September, we're asking some other local folks to take us to some of their favorite Milwaukee area green spaces, and it's kind of like a show and tell. But instead of these folks bringing an object to show you, they're taking you to their favorite places. So we're working on a pretty incredible group of people and places. If you are somebody that wants to show off your favorite green space to this community, let me know. We'll get you on the list. We've got our first 3 local hosts. So Bill Miller, Eddie Daniel, and Cheryl Nen are ready to kick this series off. And then we're negotiating with a bunch of other local folks. Maybe you could compare this to like a book club. But instead of picking a book to share with the group, we're going to share an area that we find special. Um, so super excited for this to begin in September. And subscribers will get a discounted rate to the series as they support this community further. We will roll out the details as they become available, and we hope to see you as we explore Milwaukee's backyards together with a bunch of cool folks. I'm also really excited about a brand new college level course in mammalogy that the UEC will host this fall, taught by none other than our very own Amanda Tokuyama. Think of all the courses that are available on birds, Eric. Think of all the courses we can all take on birds, number of different organizations. But there aren't a lot of in-depth courses on the mammals that share our green spaces. So this is an 8-week course. Amanda is going to teach about a whole bunch of topics. There's going to be hands-on experience identifying mammals, the signs that mammals leave behind. There's going to be a lecture portion and a lab portion. So if you miss college, or you missed college, or you just want to keep going to college, sign up for this course. Really excited for it. You can register now. You can contact Amanda, or you can visit the Urban Ecology Center webpage for more information. And yeah, I'm really, really excited for this course.
No
So
tests, no grades, though.
no tests, no grades, unless you want to. You could probably convince Amanda to do that, but this should be a lot of fun, and I'm really looking forward to it. Um, Before we start to chew on our termite stories, we'll get back to what's becoming, and you probably, if you may have been following this has become kind of a comical space opera. Hopefully stays comical, and hopefully everybody stays safe. We've been following the harrowing adventure. I don't know if we can call it harrowing. It's like the layover from hell that won't end for two astronauts, Suni Williams and Butch Wilmore, who are still stranded on the International Space Station because of technical and mechanical issues with surprise Boeing spacecraft. It was supposed to be an 8-day mission. NASA is kind of taking some really important decisions right now. Depending on what they decide, it could be an 8-month mission. It is looking more and more likely that the two will return on the rival SpaceX aircraft, not the Boeing aircraft. Interestingly, they don't have the proper suits to return on the SpaceX craft, so they need those suits delivered first. Um, so they're still waiting, so are we. And as always, this one is to be continued. And as if to add insult to injury, SpaceX is gearing up for its Polaris Dawn mission, which could launch as early as August 26th in just a little bit. And the goal of this is to achieve the first private spacewalk, that noble goal of having billionaires being able to pay to undergo spacewalks for the right price. So yeah, we'll continue to monitor these situations. And we're going to shift to the featured critter, the termite, but I do just want to give my regular shout out to Stuff You Should Know, which is a huge source of information, among other things that I use here. And then my regular shout out to my new favorite podcast, Birdjoy. I love them both. Birdjoy is on hiatus, but I think season 2 will start this fall. Okay. Uh, this is a termite. And I mean, I don't know what words would come to your mind to describe it. Uh, it really is a fragile creature on its own. It's a very fragile creature. It's not like ants that are very hardy. You could, if you put a termite through what an individual ant do, it changes of temperature, changes of humidity, desiccation, the termite would not last. Um, but so it doesn't seem on its own to be a very adaptable survivor, which is true. But as a termite in a social community, a group of termites is extremely successful. So we'll quickly go down the termite family tree, starting with its grouping as an insect, which is an arthropod, eukaryotic animal. And right off the bat, when I was looking at this, I was presented with my first surprise. I was certain before researching this that termites were related to ants. I would have bet $1,000,000. In fact, I probably said that many, many times throughout my decades. Um, so in my mind, what we would, start this off was this short taxonomic detour from the primitive ant to go to the termites. It's a good thing I'm not a betting man because I'm wrong. Ants and termites, although behaviorally share a lot of characteristics and they kind of look similar, and in our human minds that want to separate things, I think it's easy for the mistake that I made. They both live in these large social colonies underground. Um, it turns out that they are not closely related. Ants are Hymenoptera. They're with the bees and the wasps. Termites are in an order called Blatodia, wonderful name. Uh, and they share their lineage with cockroaches. Um, and even this, I guess, to my defense, is different from what I learned in insect classification. And new information keeps rearranging things. That wonderful, nice and tidy Linnaean system that we learned is constantly changing. I learned about termites being in the order Isoptera, which means equal wing, because in winged termites, unlike in winged ants, the front and hind wings are the same sizes. But the latest genetic and molecular evidence suggests that termites evolved from the cockroaches. Uh, it's so I guess in a sense, termites are a type of cockroach, just like a butterfly is a type of moth. In fact, the ancestral cockroach group that gave rise to the termites is a cockroach group that specializes in eating wood. So, the pieces make sense now. In the Blatodia, there are about 4,400 species of cockroaches and almost 3,000 species of termites. But biomass wise, termites far, far, far outnumber the cockroaches. Um, so they evolved from that wood-eating cockroach about 50 million years ago, depending on what you determine. When you make that leap from the cockroach to the termites, some take it farther back than that. Um, but from here, they are no longer the order Isoptera that I learned about. They are in the infraorder Isoptera. So Isoptera kind of got a demotion from order to infraorder. So still named after that equal size of their front and back wings, which you can see in this picture. The wings are pretty much the same size, line up really nicely in the winged version of the termites. Termites are found worldwide, but much more common in the tropics because, again, they don't do really well with temperature and environmental extremes. In areas with deep freezes, you're not going to, especially if the soil freezes, you're not going to find termites. So Wisconsin does have one native species. It's called the eastern subterranean termite. But as with many of the critters we feature here, termites are spreading into colder areas with the aid of humans and our centralized heating. So it does allow termites to do a little better. And I can imagine this trend will only continue as the planet warms up. So maybe, termites aren't something we normally have to deal with a lot here in Wisconsin now. But maybe in the future we will. They are extraordinary social. They have a strong defined caste system. Even in this picture, you can start to see the different body types. As I mentioned, a single termite is vulnerable. A group of termites can be extremely successful. So if we look at the system, starting, I guess, at what we would define as the top of the social ladder, we all know that ant colonies and bee colonies are run by a queen. Termite colonies are defined and run by both a queen and a king. So the queen and the king are the only fully reproductive and fully developed individuals in the entire colony. And they're also the darkest. They're only like completely dark from head to toe. Again, depending on the species, you have a lot of variation, but for the most part, most of the workers are white. And then some of the casts, you have some variation. And then the queen and the king are various degrees of dark. So depending on the species, you can have kings and queens that look very different from each other. And sometimes they look very similar. The queen tends to be larger because of her egg laying duties. And even though they are the only fully mature and fully reproductive individuals, they do get some backup support from probably the next main caste members, which are known as secondary and tertiary reproducers. So they have different degrees of darkness. They don't actively reproduce in a given colony, but they may be called upon to do so in the future. So they're kind of the reproductive backups, the reserves. And we'll see why that's important a little later. So you have the king, the queen, the secondary, and the tertiary reproducers kind of make those top tiers of the system. And these are the only members of the termite colony that can develop wings. And anytime a termite develops wings, they also develop eyes, a system to see with, which makes sense. Most of the colony does not use sight; they're blind. But when they develop wings, I guess it makes sense that if you're going to start flying around, you do need to be able to see where you're going. When they develop eyes and wings, they're called alites. And again, only the king, queen, secondary, and tertiary reproducers can become alites. And they develop wings and eyes when they need to swarm, which is a process we'll look at a little bit later. But most of the time, even the reproductives, even the king and queen, they don't have wings. And then all of the other members, the non-reproductives, are blind and navigate the world through scent and pheromone systems. Saliva is also a very important part of termite life. Termite saliva is extremely important. It's used for many functions. They keep the eggs moist and alive. They keep the pheromone tunnels moist, which is important for survival. So saliva is used to build and repair termite mounds, and sometimes it's used in defense. So here we have termites repairing a mound using mud, saliva, and feces. Their feces is very rich in nutrients, and a really important part of soil dynamics and ecosystem health, as is their saliva. And we've done several episodes on ants and bees, and we've done a lot about, how queen bees and queen ants in particular, how they control the colony. So if a bee needs another queen, it will feed a worker royal jelly or a larvae royal jelly. If bees need more workers, they'll lay more unfertilized eggs. If they need more drones, they'll lay fertilized eggs. So that's kind of a system in which the queen kind of controls her colony. In termite colonies, the king and queen, and this is a good example of how the two can look quite different based on the species. In the termite colonies, the queen and king are both controlling things, and they're both controlling things with pheromones. And that's how they maintain their kingdom, queendom, their population size, the dynamics. And it's also where it gets super crazy. So if your royal couple realize that they need more workers in the colonies, they don't do what a bee does and just, make more workers from eggs. They do that on a regular basis. But what they can also do is they can signal through pheromones for some of the members of their colonies to go backwards, to basically regress back to the larval stage and kind of a Benjamin Button thing. So they may be, they may be one thing, and then the king and queen tell them they need to redevelop into something else, which is absolutely crazy. So I'm not surprised that millions of years of evolution has led to this crazy adaptation. I am constantly amazed. I think the equivalent would be if, maybe my kids turned out to be a politician or a lawyer, not to play on any societal stereotypes. I know wonderful politicians and lawyers, but let's say, hey, I didn't want you to be a politician. Um, I want you, my children, to go back to being a 6-year-old, and then we'll start over. And this time you're going to be something, like a teacher or a musician. Um, and I don't know, there's something a little desirable about that because my kids are growing up way too fast. But if we're talking about termites, and if a queen and a king termite need more soldiers, they order some workers to visit the fountain of youth, regress back to larvae from nymphs, and redevelop into something new, which is insane. So, um, you know, if I guess from a social justice standpoint, if you are in an unfair caste system, you're not necessarily in your caste permanently because the royal family may order you to move into a different caste, and you age backwards into a larvae, and then you emerge as something new. So if we look at the rest of the caste after the reproductives, you have the soldiers, which, as you probably guess, are nest and colony defenders. Primarily, they're defending against ants and termites. Ants and termites are both filling a very similar niche, and so they come in contact with each other. They're social groups, and there's a lot of conflict. So both ants and termites have soldiers. Soldiers have slightly darker heads and bodies, not quite as dark as the reproductives. There are many ways that they defend the colony, starting with the obvious, those huge and powerful mandibles, which they can use to kill and maim. If that doesn't do the job, depending on the species, they have a lot of other ways of defending themselves. So in some individuals, they will shoot their feces, their poop, their frass at invaders, which is probably effective. If the poop doesn't work, they can, if the poop and the mandibles don't work, they also can spit their saliva at you, which, probably seems like the better of the two options, until you realize that termite spittle can range from just sticky and gummy and gross and like, I don't want this on me at best, to toxic and fatal at worst. So depending on the species, it can just make you having a bad day, or it can kill you if you're another termite. And in some species, the workers take it to a larger level. As they age, they develop a blue sac that is filled with toxic fluid. And if things get really bad and the colony is being invaded, they will explode this sac, which kills the individual, um, but also probably takes out a number of the invaders as well because it's really toxic. So it's a suicidal, altruistic behavior on the part of the worker, sacrificing themselves to protect the colony. So those are the workers. Incidentally, like bee drones, termite soldiers are great fighters, but paradoxically, they're also completely helpless. They can't feed themselves. So I don't know if it's the mandibles that make it impossible, but the only way that soldiers can eat are when worker termites come and feed them. So big and strong, but also completely helpless at the same time. And this photo, you can kind of see, if you're a little bit familiar with insect development, you look at this worker, it looks like like a big individual, but if you look at that abdomen, it looks much more like a nymph. Like if you ever dig up a nymph larva beetle or something like that, that's kind of what it looks like. And so when the king and queen orders these individuals to shift, they're not going backwards from a fully formed adult. They're going backwards from this kind of semi-adult, semi-nymph stage, back to larvae. And so it's still amazing, but it maybe makes it a little bit easier to understand that, I don't know, super impressive either way. And then you have essentially what is the lowest class in the caste system, the worker termites. They're completely white or creamy, maybe describe them as colorless. But if they're reflecting all the colors, they're reflecting white. So anyway, however you want to look at it, lack of color, white, black, that kind of thing. Uh, they are the lightest individuals, and they're workers. They do all the work. They dig tunnels all day. They gather food. They tend to and babysit the queen's eggs and larvae. They feed the rest of the colony. They feed the king and the queen and the other reproductives. They feed the soldiers. So they're workers, and again, they'll stay workers unless the royalty decides they'll become something else. So those are the main caste systems: the reproductives and the different levels, the soldiers and the workers. And then we all know that, you know, termites, the worker termites, are eating wood. And this is true. They do love to eat wood, among other things. It's they're one of their primary sources of nutrients. Normally, pre-humans, the wood they'd be eating would be a dead tree. So they are nature's recyclers, playing a really important ecosystem role. But in the presence of humans in our dwellings, they will also eat the wood that forms our houses. They are ingesting the wood, but technically they aren't eating the wood. On their own, the termites can't ingest and break down the cellulose that makes up wood. In order to break down the wood, they need an enzyme, just like we can't break down sugars without our enzymes. And the enzyme that they are lacking that would break down cellulose is cellulase. So the termites don't produce cellulase. Instead, they have this awesome symbiotic relationship with a bunch of critters in their hindgut, the bacteria, protozoans, and this is the gut community that is able to break down the wood into a form that the termites can use. So without this gut community, the termites couldn't survive, and vice versa. The microorganisms in the termite gut couldn't survive without the termites. So it is true symbiosis, probably. Uh, the the termite provides the bacteria with shelter and food, and the bacteria in the protozoa break down the cellulose uh, in wood into glucose, which the termites use for energy. So alone, they're helpless. As a team, they can eat wood, which is pretty badass. And what's even more badass is that some species of termites farm their own mushrooms. So they grow and tend fungi farms, not to eat them, although they will sometimes eat some spores to get some enzymes in their gut. But they farm mushrooms, uh, so that the mushrooms can help break down the cellulose into forms the termites can eat. So it's like an extension of their hind gut internally, except this is a system that they maintain externally to help them digest. So it's a little different from the leafcutter ants. Leafcutter ants farm the fungus also, but they farm it for food. They actually eat the fungus. The termites farm their own fungus like the leafcutter ants, but this is like an extension of their gut. So they have the bacteria in their hind gut, the fungi in their environment, and both help them break down wood and other food for them to eat. We group termites essentially based on where they live. Here in Wisconsin, we have one native species of what's a part of the primitive termite group. So when you go out in the parks and you roll over a log and you see some termites living in the log, those are the primitive termites, the one species that's native to Wisconsin. They don't have these big termite mounds and communities that other termites do. They essentially build their nests in whatever it is that they're eating. So if a log falls, the termites get in there, set up shop, set up their colony. They will basically at some point decompose that entire log, and when the log is gone, the colony is done. It's over. They'll go spawn a new colony, but that particular colony will die. So I get the native Wisconsin species is the primitive termite, and about 25% of the 3,000 termite species around the world are these primitive types. The other 75% are the subterranean termites. They have underground nests that can be really, really extensive, not expensive, extensive. So you might see this part of the termite nest, but like an iceberg, that's just a tiny part of what is likely a vast underground system. So these are the mound building termites. And, sometimes you'll see them setting up their colony in trees or even into your house, or parts of their colony, I should say, as they expand. Another characteristic that differentiates the termites from the ants and the bees is that, again, the colony is run by a king and a queen. That's pretty rare if you think of all the major social groups. They're dominated by a queen bee, a queen ant, and all of her colony are sisters, so very closely related. That sets up an entirely different system. When you have a social system run by a male and a female, it changes things a little bit, especially given the fact that at least in some species of termites, the queen, once she's impregnated, she can store enough sperm to essentially lay eggs for the rest of her life without the king, and that's what happens in ants and bees as well. The king and queen in the termites are basically in what we see as a monogamous relationship. For whatever reason, she decides to keep him around. There is some evidence to show that maybe for some species she is not able to store enough sperm for her entire life. So even though, and they live a long life. The termite queens, depending on sources, can live anywhere from 20 years to 70 years, which I can't imagine an insect, a queen termite, living as long as a human. But they have very, very, very long lives. And they are starting to, for the folks that study termites, give us windows into the science of aging and how these termite kings and queens, can live so long. From a genetic perspective, we're studying that in terms of, aging and anti-aging and slowing the aging process. So if they live that long, she might need to continue to mate with the king and have more sperm at various times in her life. The king termite also bucks the trend in that he is actually helpful, we think. So, male bees, drones are pretty useless. They're essentially needed for sperm and they don't do anything. The king termite attends to the colony as much as the queen does, we think. I mean, obviously different roles. So he will care for the brood. He will bring her food and water. Of course, he has a lot of help from all the workers in the colony who do the vast majority of the work, including childcare, as was recently reported by a Dr. Ed Vargo at Texas A&M University. No idea if he's any relation. I guess we're all related, technically. But the king and queen do live in a protected chamber deep in the colony. They're attended to and fed by the many workers. And then when they're being fed, that's when the royal couple can also communicate with the rest of the colony via pheromones. It's that kind of mouth-to-mouth interaction, and then that can spread from the royal chamber deep inside the colony. The queen termite basically lays lots and lots of eggs. In some species, thousands or tens of thousands of eggs per day. In some species, she's almost comically large because that abdomen is a very large ovary factory, kind of an assembly line for spewing eggs, but she can still walk around. Let's see. If you look at the life cycle of a termite, it's similar but different to the other different from the other social insects. So starts with an egg, fertilized egg hatches as a larvae molts, and most likely will become a worker or a soldier, depending on the number of molts. Most of them become workers under strict control of the queen and king. Some become reproductives, and then you have that reverse molting going on as well. If the colony gets too big, then the king and queen will signal some of the reproductives to grow wings and eyes. And then they will also undergo a physiological shift. Almost every termite kind of spurns the light. They go away from the light. Once they develop eyes and wings, they go to the light. They're attracted to light. And that often brings them to an opening in the colony. And then on a warm, humid night, remember, termites are very susceptible to being dried out. On a warm, humid night, the new winged reproductives will go out on a nuptial flight, which is similar to bees. And basically, all these reproductives will gather and look for a mate. If they're successful, they're also very vulnerable. This is a time when, like, birds and other predators are really excited because there's tons of termites to eat. But the ones that are successful in finding a new mate, they'll go off to start a new colony. These nuptial flights are often synchronized with colonies that are very, very far apart, which helps to keep the genetic diversity strong. Also, that, overwhelming the predators too, so that some will survive. So just like with bees, it's a swarm, it's a nuptial flight. And then once a male and female have found each other and mated, they will look for a new shelter. They'll lose their wings, so that's a sign of a good night out, and they will seal themselves in a new chamber with their saliva and their poop, and then she will start laying eggs. So early on, in the first couple of days of their newlywed chamber, they both have a lot of work to do because they don't have help. So they're doing all the work themselves, both of them, and then eventually their offspring are able to start taking over most of the chores. A given colony can take 2 to 4 years to become fully mature, but then once the colony is formed, it can last for many, decades. And then the process starts all over again. So when you look at the colonies themselves, mentioned that a lot of these subterranean colonies most of it is underground. We can't see a lot of it. But if you see something like this, you have a good idea that something massive is going on underground. If you take it to kind of our backyards, the underground portions are kind of like these mega ant farms. So they'll have a huge complex of rooms and connected tunnels. There'll be storage areas. There'll be nurseries. You have the royal chamber, of course. And the system works for so many reasons. It's good for defense. It can tap into local resources like trees and tree roots, houses, without exposing the colony to the air. It's built for defense, for growth and temperature control. So sudden changes in environmental temperature can be really bad for them. So this complex allows them much greater control in temperature and humidity. Uh, it's if you think about, humans tap into geothermal heating because it's a constant temperature. It's the same with the termite colonies. If they can go deep enough, they're going to start to get a regular, uh, less, more stable temperature. And they basically have these built-in ventilation systems and chimneys so that if it does get hot, the hot air is forced out and cool air comes in. In fact, there is a mixed-use development complex in Harare, Zimbabwe called the Eastgate Center that is termite-inspired design. And so there's no HVAC system, but they use that mechanical structure to heat and cool. And it is basically termite inspired. They studied termite mounds, and through biomimicry, bioengineering, they basically built this building to heat and cool itself based on the same structures that a termite mound works. They don't do well above the ground, and so if they do need to get above the ground, they will basically bring their shelter with them. And so oftentimes you'll see these shelter tubes that allow the colony to expand without being exposed to the elements. And a lot of times in the tropics, you'll see these in trees, and sometimes they'll have, their colonies up in trees or colonies up in trees connected to the ground. And if you or another animal were to come up to one of these tubes and break it, you'd see the little workers and soldiers running back and forth underneath it. So if you do live in an area with termites and you see these shelter tubes leading to your house, it might be time to come up with a plan. And termite colonies are absolutely impressive and can be massive, not only as an individual mound, but they can also just completely dominate the landscape in these termite super cities. So there's an area in Brazil that has 200 million of these large termite mounds. 200 million, which seems impossible, but they're spread over an area the size of Great Britain. And so the whole thing resembles just like an ancient human civilization. A lot of times these mounds resemble human structures, all built with mud, saliva, and frass. And each mound can contain tens of millions of termites. And these structures are built to last. They will and do easily outlast the colonies inside them. If a queen lives 50, 60, 70 years, that mound is going to last much longer. Even if you have a brush fire or a flood, the termite mounds will often survive even if the colonies inside them don't. So really, why should we care about termites? It's impossible to come up with a complete list. It's a huge list. They are essential to most ecosystems. Starting with the easiest parts, they're food for a lot of predators. They feed the world. They support food webs as a base food, a staple like rice and beans. So a lot of animals rely on termites for their protein. And termites are being born thousands per day. So there's a lot of them out there. So other insects will eat them, reptiles, anteaters, birds, the chimpanzees that fish them out of the mounds using tools. And us in humans and in most parts of the world that aren't named the United States or Canada or Europe, people eat insects, especially termites, in areas that didn't come from, or be colonized by folks from those other areas. So in Singapore, people eat termites dipped in rice and wine. And I'm not sure why we don't eat them. Our ancestors surely did, and we're probably missing out. Termites also eat and break down a lot of materials that release very important nutrients. So yes, they eat and break down wood. That's super important. They also might be the only decomposer in an area that's breaking down all the herbivore poop. So they're really, really important in basically, recycling, spreading nutrients. They're wonderful for healthy soils. And some studies show that in termite-rich areas, basically 90% of the species are benefiting from the termites being there and would be negatively impacted if the termites weren't there. And even these elephants agree that termite mounds are super useful for scratching that nagging itch. Or to cheetah or another one of those herbivores, a termite mound could provide cooling, because just like if you hang out by a cave entrance, sometimes these termite mounds can be quite a bit cooler than the surrounding area, or they can provide shade, or they can provide a high vantage point for the predator or to look for predators. Uh, they are wonderful for the soil. A recent study out of Princeton University reported that termite mounds serve as basically oases in the desert, just not water oases. So they allow surrounding plants to persist on basically a fraction of the rainfall that they would normally require. And it helps communities rebound after drought. So, might be a very, very important tool in the struggle against climate change and desertification, which might otherwise decimate a local community. Super important to the living and non-living components of an ecological community. They're the ultimate soil engineers. They help nutrient retention. They resist against erosion. Uh, there's another study out of Louisiana State University that I love. It shows that uh, as an organized society, I think we could learn a lot from them. But one of the studies showed that when a termite mound is under attack, and my guess is that when that happens, all the termites just kind of run around screaming, right? We're under attack. The response is way more methodical than would appear to us, and way more methodical than compared to other animals, including ants. So there's no stampeding, there's no like mob activity, there's no panicky behavior. The study shows that when a termite colony is under attack, they the individuals act in an extremely orderly fashion that's based on rules and based on what caste they are. So workers will fall into single file formations. And then whoever's in front is going to decide, they're going to be the leader. They're going to decide which direction to head, and the rest of the workers follow them. Uniform speed, uniform spacing. The soldiers immediately shift to the side of the worker lines in a defense formation. If an individual stumbles or slows, they don't just get trampled over. The line waits for them, helps them. So even compared to ants, they're way less selfish. If an ant colony is under attack, you do get more of this, I guess what we call mistakes, crowding, getting trapped, kind of more of what we would look at as mass panicking. But for termite, it's like, okay, we're under attack. I know my role. And they follow it. And then, that's a successful adaptation. So certainly more termites than humans in the world. They even outweigh ants in biomass in some tropical areas. This helped me look at them maybe more as an advanced cockroach than like an ant cousin, which probably doesn't help them with respect to human impressions. But overall, very, very few species are pests to humans. The vast majority of termites are essentially the backbone of ecological communities. And again, they're not that important here in Wisconsin, but they are important to humanity, right? And so if you are one of the 90% of the species that benefit from termites, which we are, I think they're going to start to go into my gratitude system of what's helping me in ways that I'm not aware. A lot more can be said about termites. Easily could be 2 or 3 parts, but again, they're not a big part of the area here in southern Wisconsin. So thank you for joining me. I will stop sharing my screen now, and I will stop recording.